The final version that I'm going to show in my videos of finding magnitude is actually more about notation than about anything else. Unit vectors are these little things called I and j, and sometimes I'll draw them with this little like I hat instead of a dot like I've done up here. And then we have this j hat as well. These vectors are represented a little differently, but really all this is, I and j are called unit vectors. The idea is a unit represents a single thing. It's basically the number 1. I represents a vector of length 1 in the x direction. That means it has no y component. And j in the other direction would be no x component, but moving vertically by 1. So the idea, again, being this would be a vector to the right by 1, this would be a vector up by 1. There's nothing really fancy to this. What this really is a way up here to rewrite this in a different form. I don't particularly feel that there's a very big need in high school pre-calculus for this version, but this right here, all this means is that b is the vector 3, -7. It's telling you that your x component is 3, your y component is -7, and then from there you can do exactly what we've done in the last couple of videos. You can breathe a sigh of relief because they've done all the hard work for us of just locating and finding what these values are. And we're just going to go in and say, well, look, we know the magnitude of our vector is the square root of our sides squared, or our components squared, added together. And so from this point, this is going to be 9 plus 49. It's going to be the square root of 58. And you would want to ask yourself, that is an even number. Our last couple of videos had some really obviously prime values. You'd want to check to make sure this doesn't break down any, or round it off using a calculator, depending on what you would be asked to do. But I would notice here that this is 2 times 29 inside the parentheses, or not the parentheses, but the radical. It's be 2 times 29, and both of those are prime. So this looks like we would stop at the square root of 58. So don't be thrown off by this whole 3i minus 7j thing. This right here is literally saying, look, we're going to go 1 3 times in the x direction. That's what 3i means. So this would be 3i. But that's just a total distance of 3. And -7 is literally 1, 2, 3, 4, 5, 6. I'm running off the screen. 7. And that's the whole idea here, is 7i just means a distance of 7 in the negative direction in this case. And that's all that is. So our vector, our resultant, would just be this thing here that we just found that had the square root of 58. So the I and the j really don't mean much, and I just realized that I wrote an I instead of a j here, so I apologize for that. But that's all that is. It really doesn't mean anything. I and j are just the number 1 effectively for what we're doing here.